Today we are going to determine the size of the transistors. So we have the pull up and pull down network here, and we're going to determine the size of the transistors for both pull up and pull down. So what is the first step? So the first step is understanding the concept of UniCMOS. As you can see, sorry, let me erase this one more time and draw it nicely. So the concept of UniCMOS, we have to draw an inverter first. So this one is the PMOS, right? And this one is the NMOS, sorry. So the size is 2 here, and the size is 1 here. So we have to follow this concept. I know it kind of looks weird, but you have to understand that we always have to multiply the size of the PMOS by 2 and the size of NMOS by 1. So that's the most important thing that we need to understand to determine the size of the transistors. So for the pull-up network, after understanding the concept of UniCMOS, we move on to the next step. The second step is understanding the series connection. So we have to understand the series connection. If we understand the series connection, it will be same as for the parallel connection, it will be same as the series connection. So here we are going to start from the pull-up network. So for the pull-up network, I'm going to highlight which of them are in series. So as you can see on screen, B and D, they are in series, right? So how many transistors are there in B and D? So B and D, they are in series. B and D, when you count them, B has 1 transistors and D has 1 transistors. So total transistors are 2 of them in series. So B and D, there are 2 transistors. Number of transistors, 2, right? Let me erase this, sorry. So there are 2 transistors, B and D. Now, what we have to know is we have to know the concept of UniCMOS. So what is the value of PMOS of UniCMOS? So it's 2, right? So number of transistor 2, the value is 2 times 2. This 2, we get it from here. So 2 times 2 is 4. So since this and this, they are in series, they are going to have the same value, which is 4, right? So as I've already said before, if you get a series, it's easy to get parallel because it's the same thing. So if you get the size for series, it's going to be the same size for parallel, so you just put 4 here. And you put 4 here as well, right? Okay, now the interesting part. You can see here on B and C, right? B and C, and this is an A. This is an A. I know it's connected all the way up here, but this is an A. This is B, this is C, and this is D. So as I've already said, like it's if I have the size 4 here, it's gonna be 4 in here. Yeah, it's gonna be 4 in here as well. But here the number of transistors are 3. So A, B, and C, there are a total number of 3 transistors. So 3 transistors times 4, it will be 12. So here, A will be 12, B will be 12, and C will be 12. So I'm going to repeat one more time. I know I said like it's gonna be the same value, but since we have three transistors here and there's only one transistor here, we multiply by 3 times. So it's gonna be 3 times 4, it's gonna be 12 here. So we are done with the pull-up network. Now we are gonna focus on pull-down. So for the pull-down network, what we need to understand is we still need to understand the concept of an unit CMOS, but for NMOS, we are going to focus on NMOS. And the NMOS value is 1. The size of NMOS is 1, so it's kind of easy for pull down because all you have to do is multiply by 1. So how many transistors are here? 1, 2, and 3, right? So total number of 3 transistors. So 3 multiplied by 1. So it's going to be 3 here, it's going to be 3 here, and it's going to be 3 here. Right? And for this one we have D and B, they are in series. So how many transistors are there? Number of transistors in series, there are 2. 2 in series. And we multiply it by 1, the size of NMOS. So this will be 2 here, and this will be 2 here. This will be 2 here, and this will be 2 here. I hope it makes sense. At the end, this will be our final result, the size of the transistors. Thank you.